Groundwater is the water right beneath your feet. If we would drill a well right here, or wherever you're standing, we'd find groundwater. And that's exactly what we're doing in Vermont. We're drilling wells to study how groundwater flows around faults. And we're doing that in collaboration with the University of Vermont and the Vermont Geological Survey.
In addition to being important structures to control groundwater flow today, these faults have a life history of their own. So through this drilling project, we really have the opportunity to get inside the fault structures.
So if you just break it down, a fault is basically a fracture, a break in the rock, along which there's been motion.
Faults can either channel groundwater to flow along them, or they can be barriers that prohibit groundwater from passing from one plate into the other.
So when we drill, we get little chips of rock, and we collect those chips of rock every 5 feet. So all these bags and piles of rocks here are little chips of rocks from our drill holes in Vermont. And you can see actually the transition from the very light colored rocks, which is in the foreground here, and that's what's on the upper part of the fault. And on the lower part of the fault are these dark rocks here, this shale. So where I'm standing right here is actually where the fault zone is in Vermont. So we've sent a waterproof camera down the 2 wells we've already drilled. And what we can see using this camera is where the shale actually meets the dolostone. And that's what you're looking at here. This is the fault.
We're going to drill 5 wells at the site. Our drill rig is going to come in and drill 6-inch hollow cylindrical holes through the rock formations and the faults. Once the wells are completed, we're going to do some testing to figure out how water moves through the rock formations and the faults.
Okay, the Champlain Thrust is world famous. A lot of people come here, and one of the reasons is because we can walk around on it on the surface.